first of all, that first sentence, really, that material, we don't need to really use this material right here, because what we're interested in is that you are given a height function for the ball. And so what's happening is that the path of the ball is given by this function, which hopefully by now, based on your work, you know that this is a parabola, right? Because it's got the t squared. It's a quadratic equation. It's a quadratic function, and it's a parabola. And here's the thing: the a, right? The coefficient of t squared is negative, so you should know that the parabola opens downward, and the height of the ball is given by this function, which means that when you substitute in a value for t, and t is how long has the ball been in the air, right? Because t is the number of seconds after Susan throws the ball, okay? So when you substitute in values for t into this quadratic equation and you do the math, the answer that you get back out is the height of the ball at that particular time. So if you put in t equals 1 and substitute in here, then you would be finding the height of the ball at 1 second. If you put in t equals 2, you'd be finding the height of the ball at 2 seconds, and so on, okay? Well, we want to find the maximum height of the softball. And because we know this is the function with the path of the softball, and we recognize it as a parabola, we know that the maximum height of the softball is going to occur at the vertex. So really and truly, this sentence here, what is the maximum height of the softball? It's just asking us to find the vertex of that function. Okay, so here's the function again. Okay, and again, A is negative 16, B is 32, and C is 40. Okay? So now we're going to use the fact that the x-coordinate of the vertex is at the opposite of B over 2A, right? So we read that in the book. And so we're going to write the opposite of 32, because that's our B, over 2 times A, and A is negative 16. So now we have negative 32 over negative 32, and negative 32 divided by a negative 32, as you know, is positive 1. So you have just found the x-coordinate of the vertex of the highest point of the parabola. So remember that x, and actually I guess I apologize to you, I should be using t here because our independent variable is t, not x, so this really should be t. So we have just found that the vertex of this parabola happens at t equals 1. So when the ball has been, when Susan throws the ball, 1 second after she's thrown it, it reaches its highest height. Okay? So we need to find that height, because as the question is, find the maximum height. So we're going to substitute t equals 1 into the original equation. So negative 16 times 1 squared plus 32 times 1 plus 40 is what we're trying to, this will be the height. Okay? And so now you do your order of operations. So we're going to square 1, which is just 1, as you know, times negative 16 is negative 16. 1 times 32 is 32. We do multiplication here. And now we can add. And over here on the right, I have a 72. And I have a negative 16. And so it looks like 56. So it looks like 56 feet is the maximum height of the ball, right? Okay, now it says, so that's the first question. What is the maximum height of the softball? The second question is, how many seconds does it take to reach the ground after first being thrown upward? And so, and you know what's happening is this, because we talked about this being a parabola, right? And now you've just found that at t equals 1, we've got our highest point, and it's at 156, right? And so this guy, is being thrown and then coming back down again, and then finally it's hitting the ground, right? Okay, so that's what's happening. This is the highest point, and then the ball starts to drop, and you're looking for what time does it hit the ground? Like how long is it flying before it hits the ground over here, right? So basically what you have to remember here is that we don't know t, that's what we're looking for t, but we do know h because h is like our y-coordinate, right? H is the height. And if this is the ground, then how far off the ground is the ball? Well, the ball is 0 off the ground, right? It's on the ground, so the height is 0. So to answer the second question here, we're going to write 0 equals negative 16t squared plus 32t plus 40. We're going to solve this quadratic equation, and we're going to use the quadratic formula to solve it, all right? Now, here's the thing. Just to make my number smaller, I can see that all of these coefficients here, all these numbers are divisible by, looks like 8, right? So we're going to go through, I'm going to go through and divide both sides of this equation by 8. And so then I'm going to get 0 equals negative 2t squared, right, divided by 8 plus 4t plus 5. So that's way nicer now to use this, right? So then we're going to go t equals the opposite of b, negative 4, plus or minus the square root of b squared, which is 16, 4 squared, minus 4 times a times c. A is negative 2, c is 5, so when you multiply those two, you get negative 10, right? All over 2 times a, and a is negative 2. Okay, so now what I'm going to do is I'm just going to put, just simplify that and get some decimals here. Because it said round your answer to the nearest tenth. That's a hint that they want a decimal, right? Okay, so what I did was that I went to my graphing calculator, and so I added here the 16 plus 40 and got 56 and square root of 56, and then I came over here to my graphing calculator and I first put negative 4 plus square root of 56, found that decimal, and then divided by the negative 4, just like it says here. I did it like in 2 steps. This time I got a negative 0.87, and t is time, so the ball was at the ground before it was thrown. Yeah, possibly, but that's not what we're looking for, right? So we're gonna not use that answer, and we're gonna come to this one, which is negative, and this time I use parentheses to do it all in one step. Negative 4 minus square root of 56 divided by negative 4. And now I got 2.87. And since they want the answer in one decimal place, then we round up to 2.9 seconds. So the answer to part 2, t equals 2.9 seconds. So I hope this helps, but mostly I wanted you to see that the book does have some other features to help you this week as you do section 9.5.